Okay, here are a couple of examples to illustrate the perpendicular and angle bisector concepts where we have points of concurrency, the circumcenter and incenter. So let's take a look at this first one. You want to locate a new fire station equidistant from the elementary, middle, and high school. So here's a map. Where should that fire station be located? So first thing I would do is I would connect these dots. There's your high school, H, elementary, E, and middle school, M. I would create a triangle here. So let's just go ahead and draw that right through. Doesn't have to be very large. There we go. And then I'm going to construct the perpendicular bisectors, because the perpendicular bisectors are the ones that are equidistant from the vertices of the triangle. So I'm going to take my compass. I'm going to make it larger than half of one of the segments. Let's do HM first, and we will draw the perpendicular bisector. So I have to construct that here. So I will take that and I will draw my curve here, and then the same from over here. Whoops, make sure I get that right. All right, so there's that. So if I draw the perpendicular bisector through this point and this point, so somewhere on that line will be the fire station. Now I'm going to do this again to a different side. Let's go ahead and do this one, EM. So make sure I'm more than half of EM, so that's probably fine right there. Let's draw that. And then we'll come to this one. Intersect it there and there. So it's kind of messy, but you got to look and say, this one was this curve and this curve. So we have this point and this point. So we want to draw a line through there. Okay, now we could do it through the perpendicular bisector of this side, but it really doesn't matter because we've already intersected right here. And so in theory, the perpendicular bisector of this side would also go through that point. So I've already found the point. So this is the location where the fire station has to be found, because it's equidistant from M, from E, and from H. All right, and there's your first example. Let's take a look at one more example here. This one says that GE is 2x minus 7 right here, and GF is x plus 4. What is the length of GD? Well, take a look. This segment is the angle bisector of the triangle. This is an angle bisector of the triangle, and this is an angle bisector. So this is the point of concurrency. And so on the angle bisector is point G, and it's also, so that means it's equidistant from E, from D, and from F. If you wanted to, I could draw, maybe I will, draw a circle. As long as I'm fairly accurate here, I could draw a circle that would touch DEF right through here. Let's see how good I am at this. Not quite right, but it's pretty close. It's pretty close. And so this distance right here is congruent to this distance, which is congruent to that distance. So knowing that, we can just say, well, these are the same. GE is this one. GF is this one. So I can set these two equal to each other. So I can say 2x minus 7 equals x plus 4. I could solve that for x. So if I subtract x, I'm going to get x minus 7 equals 4. Add 7 gives me x equals 11. Not quite done with the problem. Remember, the question is, what is G and D? What is that length? Well, it's the same as all the others, so I'm just going to pick one of these. I'll pick this one, and I'll plug 11 in there. So GD would be the same length as x plus 4, or 11 plus 4, which is 15. So all the segments are actually 15 units long, and so is segment GD. And there's your examples for section F3.